Hello everyone. I am going to go ahead and discuss solving and graphing linear inequalities. Now, when it comes to solving these linear inequalities, you solve them just like you would solve an equation. The difference is this, guys. When you are solving, here, let me write this down for you guys. Solve using the same properties of equality. As in, adding to both sides, subtracting from both sides, dividing by both sides, and so on. But when it comes to solving these inequalities, guys, don't forget to use inverse operations, right? So the biggest difference is this, okay? Let me use a different color here. This is the big difference, guys, right here. So if you should have to divide or multiply by a negative, that's a G right here, a negative, you must, okay, change, reverse, those all mean the same thing, flip the inequality symbol. And I like to abbreviate. And the inequality symbol, now, I need to go back a little bit. Flip, switch, reverse, change the inequality symbol. So guys, the question always comes up, why do we need to do this, okay? First and foremost, I went a little too fast. So let me go back just slightly and talk about the symbols themselves. So you have first the greater than symbol, greater than. Then you have the less than. Then you have greater than or equal to, greater than or equal to. And then finally you have less than or equal to. And these are your basic inequality symbols, less than or equal to. I'm just going to be lazy here. Less than or equal to, okay? Now, there's a last one we don't often talk about, and that is the not equal to, but we rarely use this, okay? So these are all your inequality symbols. So that's the question I had posed earlier. The question is, why do we need to reverse the inequality symbol? So I am going to go ahead and give you this example right here. Negative 4x is less than 12. Now, if negative 4x is less than 12, guys, and you wanted to solve this, let's say we forgot about the fact that this was the reverse inequality symbol, and we end up with x is less than negative 3 as the solution to this inequality. If it is a solution to this inequality, this means any value less than negative 3 will make the original problem true. So we're going to go ahead and test out this theory. We're going to select the value less than negative 3, and we're going to check the solution. So let's say we choose negative 5. If x is less than negative 3 is clearly the answer, then when we substitute the negative 5 in, it would make the original problem true. So I'm going to work it out. I get 20 is less than 12. And obviously, that is absolutely false, completely and totally false. So since we selected the negative 5, which is less than negative 3, and we tested it out, it doesn't make the original problem true, we cannot count this as the solution. However, guys, if we were to go back to the solution, the inequality, okay, and we were to go ahead and reverse the inequality symbol so that it reflects x is greater than negative 3, this would mean every value greater than negative 3 will make the problem true. So let's test it out again. Let me check it. My favorite number to check with or to test with is x equals to 0. So I'm going to go back into the original inequality, plug in 0 for x, and make it happen. What do I get? I end up with 0 is less than 12, guys. Is 0 less than 12? Absolutely true. So since 0 is a number greater than -3 and it makes the original problem true, then this means that every value greater than -3 will also make the problem true. Now, this is the reason why you must reverse the inequality symbol, guys. So if you don't reverse the inequality symbol, you would end up in a solution which doesn't make sense within the context of the problem. In other words, you would end up with a false solution. To make sure you are reversing, flipping, switching the inequality symbol. Now, I need to mention this next part, guys. You're never gonna see it again. I mean, you might see it again, but I'm not gonna mention it again. And that is set builder notation. Now, this is another way of writing the inequality for the solution. So when you write set builder notation, if we're writing x is greater than -3, we would start off with the braces, identify the variable in question, such that the inequality x is greater than -3, and then you want to go ahead and close off the braces. This is set builder notation, the set of x such that you want all x's greater than -3. That's what set builder notation is. So this is the only time I'm going to mention this, guys. After that, I'm not going to mention it again. Now, besides solving the inequalities, you're also going to have to graph the inequalities, okay? Now, when it comes to graphing the inequalities, guys, so are a few things to keep in mind. When the inequality is greater than or less than, we're saying the boundary value is excluded, as in it's not included as part of the solution set. Not included. So when we show this graphing on the number line, we're going to use an open circle. Here, let me use a different color. We're going to use an open dot, open circle. However, guys, at the college, okay, once you get into the college level mathematics courses, you're going to have to use the parentheses to show that the boundary value is excluded from the solution set. Now, I will show it to you guys later on as to why we're using parentheses instead of the little dot or the little circle here. So I'm going to go back to that solution, guys. X is greater than -3. If I wanted to graph this one, I would go ahead and sketch out my number line. I always plot a zero to separate the negative side from the positive side of the number line. Next, I like to keep this very neat and straight to the point. So I plot my boundary value, which is on the left side of the circle, okay? And then I am going to go ahead and look at my inequality symbol, which is greater than. So I'm going to use a parentheses on the -3. And I want to put on display all the values which are greater than -3. That's every value to the right of the -3. And of course, the set of solutions will continue all the way up to the right, to positive infinity. If they were to continue indefinitely to the left, they would continue on down to negative infinity. So guys, this is the basic step for graphing linear inequalities. Now, additionally, okay, here comes the next part of it. If you are graphing with greater than or equal to, less than or equal to, you're saying the boundary value is included as part of the solution set. And if it is included as part of the solution set, when we graph on the number line, we're going to use a shaded circle. And of course, when you get to the higher level math courses, you're going to use the closed brackets, the square brackets, to show that the boundary value, okay, is included, or your interval is a closed interval. Now, the other thing is this, guys, okay? In the previous one, I said it's not included or it's excluded. We could also call this an open interval. Open interval. I'm running out of room here. Open interval. Okay, same thing. So guys, be careful when you are graphing on the number line. Once again, if you have greater than, less than, open circle, or in some instances, parentheses, But if you're graphing greater than or equal to, less than or equal to, you want to use a shaded circle or the square bracket. So let me do a quick example with the square bracket. If I was graphing x is less than or equal to positive 2, I would go to the number line. Once again, guys, I like to keep it simple. Plot my 0 so I can separate the positive from the negative side on the number line. Plot my boundary value. Then I'm going to look at my inequality symbol, which is less than or equal to. So I'm going to put a bracket on the 2, above the 2. And I'm going to show every single value that is less than, okay, less than. And guys, just like that, we're done with the graphing. Now, additionally, guys, there's one more component we need to talk about, and that is writing the solution set in interval notation. Now, when we're writing an interval notation, guys, writing solution sets in interval notation, we are simply expressing the solution set to an inequality. Essentially, we're taking the information off the number line and rewriting it without the number line. We are taking the information off the number line and rewriting it without the number line. So guys, there are two rules that govern interval notation. Number one, it must be written, it is written in numerical order from left to right. Just like you're reading a book, from left to right, in increasing order, guys, from left to right. Just like you're reading a book. There's a different color here. Left to right. Now, additionally, number two, here's the second rule for interval notation. When you're writing interval notation, you always, guys, use, and I hate using the word always, but in this case, yes, always use parentheses with positive infinity and negative infinity. Always use positive infinity at parentheses with positive infinity, negative infinity. Why? Because you can never include them, guys. That is why. So let me go ahead and show you guys an example. Remember earlier we graphed x is less than negative 3. And we went on the number line. We plotted the 0, plotted the boundary value, and was it greater than or less than, guys? I think it was greater than. So let me erase this over here. That's supposed to be greater than, I believe. Okay, well, I don't remember. Regardless, okay? We're just going to go ahead and graph this one. So guys, on this one right here, we're going to put a parentheses above the negative 3. By the way, this is why we're using the parentheses and the brackets to help us write the notation. And we want to show every value greater than the negative 3. So this is what the graph looks like. So now I'm going to take this information off the number line and express it in interval notation. Remember, our interval notation, guys, is nothing more than taking the information, lifting the information off the number line and rewriting it without the number line. And you always, number one, write interval notation in numerical order from left to right. And then use a parentheses with negative infinity or positive infinity. So I'm starting here, all right, on the right with the parentheses with the negative 3. And a set of numbers continue all the way to the right up to positive infinity because they keep going indefinitely. And what do we use with infinity? We use a parentheses with infinity. And guys, just like that, you have your interval notation. There's the interval notation, and that's it. Okay? So let me do another one. Now, this one right here, I think it was x is less than or equal to 2. So we go on the number line, plot the 0, plot the 2, use a bracket at the 2, and want to show every value less than 2. Now, guys, listen, on this one right here, notice I use the bracket. Notice the graph continues to the left, all the way to the left, and definitely down to negative infinity. So when you're writing this interval notation, starting on the left, the first thing you encounter is that negative infinity. What do we always use with negative infinity? Parentheses. And then the set of values continue all the way to the right up to positive 2, which is included. So this one would represent a closed interval, okay? Which means the 2 is included as part of the selection set. So guys, this is essentially what we're doing with the linear inequalities. We're going to solve them, we're going to graph in, and in some instances, you have to write them in interval notation. So what I want to do right now is look at a few examples with you guys, and then I will be done. Number one, I've got 5x minus 1 is greater than 4. They want us to solve this and then graph it. So we're going to go ahead and add 1 to both sides. So this would come out to be 5x is greater than 5. Divide both sides by the 5, so we get x is greater than 1. So there's your solution. But we got to graph it. So we go on the number line. We're going to plot our 0 on there to separate the number line. Plot the boundary value of 1. Look at the inequality symbol, guys. We're going to put a parentheses on the positive 1 and show every value greater than positive 1. Now, if we wanted to express this in interval notation, starting from the left with a parentheses at 1, comma, set of numbers continue all the way to the right up to positive infinity, and you close it up. And guys, that's it. Very straightforward. So here's another one. 3x is less than or equal to negative 18. So on this one right here, I would divide both sides by 3. So I'm left with x is less than or equal to negative 6. So I'm going to go to the number line once again. I'm going to plot my 0, plot my negative 6 boundary value. Then I'm going to go ahead and graph. Now, according to this inequality symbol, we want a bracket at the negative 3. So we must show every single value that's less than negative 6. So that's everything to the left of the negative 6. By the way, this is a closed interval because we're using that bracket. It includes the negative 6. If we wanted to write this one in interval notation, we would start on the left with the negative infinity and continue all the way to the right up to negative 6, which would close in with a bracket. 2 more examples, guys, and I'll be done. Number 3, I've got 6 minus 2x is greater than or equal to 2. Now, for this one right here, we're going to start off by subtracting 6 on both sides. We get negative 2x is greater than or equal to negative 4. Now, on this one, to finalize the problem, we'll divide both sides by negative 2. Because I am dividing by a negative, guys, I'm dividing by negative 2, I must reverse the inequality symbol. And a negative 4 divided by a negative 2 turns out to be a positive 2. So when I express my solution set on the number line to graph it, I am going to have my 0 right here, positive 2 with a bracket, and I got to show every single value less than 2. So this is what the graph looks like. And of course, if I wanted to express this in interval notation, it will be parentheses with the negative infinity on the left over here, all the way up to positive 2, and you want to go ahead and close off the bracket, guys. Now, last example, actually, you know what, I'm going to erase all of this. Last example, and this one involves a fraction, everybody. So I've got a over 2 minus 5 over 2 is less than or equal to a over 2 minus 1. Whoa, this is easy. Guys, all the denominators are exactly the same thing. That's too easy. I think I may have made an error on this one. But if that is the case, then the first step we need to do is to eliminate the fractions. To eliminate the fractions, we're going to multiply each term by a. If we take a over 2, multiply it by, I'm sorry, not a. The denominator is 2. Oops. Yeah, I got too excited there, guys, okay? So I'm going to multiply everything by 2. So if we take a over 2 and multiply it by 2, guys, the 2's will cancel out, leaving you with a. Now for the second one, same thing, the 2's will cancel out, leaving you with 5. For the third fraction, the 2's will cancel out, leaving you with a. However, on the last one, you got to multiply the negative 1 by 2, so that gives you 2. And guys, now you go ahead and solve it. I think I made an error with this problem, but we'll go ahead and finalize it because that's the problem I have in front of me. And so this cancels out, leaving you with this statement, -5 is less than or equal to -2. If this is indeed the correct problem, guys, what we're left with is a statement. So you have to ask yourself the question, is -5 less than or equal to -2? Is that a true statement or is that a false statement? This one ends up being a true statement. And because it's a true statement, this means that -5 will always be less than -2. So therefore, the solution set is going to be all reals, guys. All reals, infinitely many solutions. Now, how do we graph this on a number line? If the solution set is all reals, as in every single real value, well, we just go on a number line, guys, and just go ahead and trace over it, and this would be our graph. So how would we express this in interval notation? Well, on the left side, we have a negative infinity. On the right side, we have a positive infinity. So then the interval notation would be parentheses, negative infinity, comma, positive infinity. And that's how you would write it in interval notation. So hopefully I wrote down the correct question, but of course I will take more questions when I get to class, guys. So that's the end of solving and graphing linear inequalities. Hopefully you learned something. So until next time, bye everybody.